Good morning, all of you. In today's session, we are going to discuss about the CSIR NET December 2019 Chemical Sciences question paper. So we are going to cover entire section C part of CSIR NET December 2019 Chemical Sciences. In that, series of questions will be given to you. In each part, we are going to prepare 10 questions with the detailed answers. Okay, here it is. Our channel is World of Competitive Chemistry, where CSIR NET Chemical Science December 2019 Part C will be provided to you, right? So before entering into that, let us see one quotation which is provided by myself. Innovation is not all about invention of complex new concepts, but it is the matter of innate, inherent, interpersonal and inspirational ideology. Based on this, we can improve our interpersonal skills in order to crack whatever we are targeting for. So from this, we are going to start our CSIR NET Chemical Science Part C, December 2019 question paper. Here, the first question is the rate determining step in the catalytic synthesis of acetic acid by Monsanto process. Monsanto is the process where acetic acid synthesis is carried by using rhodium catalyst in the presence of by treating with methyl iodide, right? So rhodium complex, when added to methyl iodide, there are sequential steps. In those sequential steps, in Monsanto process, the final product will be acetic acid. The question here will be rate determining step. Wherever slow reaction will be there, that is considered as a rate determining step. In this Monsanto acetic acid synthesis, here rate determining state will be oxidative addition. In this synthesis, you can observe 4 different steps. One is oxidative addition, second is migratory insertion of methyl group, and third is addition of carbonyl. Fourth is reductive elimination and subsequent hydrolysis. Where here rate determining step is oxidative addition. Initial rhodium dicarbonyl diiodo complex is a 16 electron system where square planar complex will be there. Now it is treated with methyl iodide. Whenever methyl iodide will be treated, it is transferred into 18 electron system of octahedral complex. Now it is added with insertion of this methyl from metal to carbonyl. Whenever this methyl is shifted to carbonyl, there is a formation of vacant site and the acetyl group will be generated at the center. This vacant center can be added with nucleophile carbonyl functional group so that octahedral 18 electron system will be generated. Subsequent reductive elimination leads to formation of acid halide, which further hydrolysis gives rise to acetic acid. And here regeneration of the catalyst, that is rhodium complex, will be generated. It further in this synthesis of acetic acid. In this, the final product will be acetic acid, which is generated by all these sequential steps. Among all, step 1 will be considered as oxidative addition, which is called a rate determining step, right? So that is the correct answer for question number 1. Let us move on to question number 2. Question number 2 is given from chemical kinetics, where rate constant of second order reaction 2A gives rise to Z is K2. If the initial concentration of the reactant is A0 and the concentration of product will be X at T time, the linear function of T will be slope with K to A0 is given as. In order to predict this reaction, we have to go with what is second order kinetics. Second order kinetics, 2A gives rise to Z, rate constant will be K2, that K2 is given as 1 by AT X into A by X, right? So here, let us take this denominator term towards K2, then it is converted into K2AT is equal to X by A minus X. The equation is in the form of Y is equal to Mx, Y coordinate term will be X by A minus X, and the slope will be K2A, X will be time. So when we take this Y is equal to Mx, the equation is in the form of Y is equal to Mx. So here X coordinate term will be time, Y coordinate term will be X by A minus X. The straight line originated from this 0 point will be moving in this direction, and slope is regarded as K to A. In this reaction, so linear function for time will be X by A minus X. Hence the correct answer will be 3. X by A minus X, the correct option will be 3, right? So for question number 2, right answer will be option number 3. Option number 3 will be the right answer. Let us move on to question number 3, where we are taking vicinal dihydroxy compound, which is treated with carbonyl compound having this imidazole moieties. We have to predict what are the products in this A and B. These products should be predicted in this vicinal dihydroxy compound, right? Here, in order to get this, let us move on to its mechanism, where vicinal dihydroxy compound was taken initially. It is treated with this imidazole. It is a kind of nucleophilic addition. Lone pair of electrons present in the oxygen will be bound to carbonylic center. When here the attachment of this oxygen electrons onto this carbonylic center, what happens? One of the imidazole moiety will be eliminated. It is a kind of nucleophilic addition at this carbonylic center, and subsequent imidazole moiety will be removed. Then one more hydroxy group is also there. This is also bounded to this carbon, so that 5-membered cyclic ring will be generated, and one more imidazole moiety is also eliminated. So we will get 5-membered ring with a 2 ether, 2 oxygen heteroatoms within the 5-membered ring system, right? Now it is treated with any other reagent, POMe3 taken thrice. So when this compound is added, it will be added at sulfur, so that it is converted into carbene ion and phosphorus retaining positive charge. It is the addition product, right? Being it is the highly sterically hindered strained molecule, this leaving group is better eliminated from the center, and there is a formation of a 5-membered ring system. In this 5-membered ring system, this topmost portion is pertaining carbon dioxide moiety, and bottommost portion is converted into olefinic moiety. So that carbon-carbon double bond is generated within the ring, and one more byproduct will be carbon dioxide and trimethoxy phosphorus double bond S, right? So in this way, both the products will be generated. Here is the compound which is having trans relationship, and also carbon dioxide P double bond SOMe taken thrice. Option number 1 is the right answer for this question number 3. So option number 1 will be satisfying this statement. Now let us move on to question number 4, where substitution type of reactions are possible in various kind of starting materials, and we have to predict which of the reaction is not feasible. Among all 4 options given below, we have to predict which 2 reactions are not feasible here. In order to get this relationship, we have to choose HSAB. HSAB stands for hard, soft, acid and base concept. In accordance with HSAB, when hard acid, hard base interactions are there, strong kind of bond formation is possible. Soft interactions when present, those are also strong in nature. Whereas hard soft interactions are weak, and soft hard interactions also weak. In this way, HSAB principle is used to predict strong and weak interactions among the atoms which are combining. And one more statement is strong interactions always generates a dative bond, whereas strong weak interaction always generates a substitution kind of reaction, right? So being all 4 reactions are substitution, the possibility will be strong weak interactions. If 2 atoms combining are strong weak, then only there is a possibility of substitution. So let us see HSAB application for these all 4 reactions. Let us come with option number 4, where we are taking beryllium fluoride treated with mercury diiodide, formation of beryllium iodide and mercury difluoride is possible, right? So when this beryllium difluoride was taken, beryllium being it is alkaline earth metal and the topmost element, it is hard in nature. Fluorine is also highly electronegative and at the topmost position of halogen family, and again it is hard. Hard interactions always considered as the stronger interactions. Mercury diiodide when taken, mercury being it is a soft metal, so and iodine is also soft halogen. Soft interactions are considered as a stronger one. Strong interactions we are taking, that's why this kind of a combination may not be possible and substitution may not be possible. The option which pertaining this beryllium difluoride reaction will not be feasible. Only the option given here, that option number 4. The right answer for question number 4 will be option number 4 only, right? Let us move on to next question. Question number 5. Correct absolute configuration of the following compounds. Here, 2 compounds are given. One is polynuclear aromatic compound. Second is cyclic ether compound. When these 2 compounds were taken, we have to predict their absolute configuration. When polynuclear aromatic compound system was taken, there are 2 possibilities. If clockwise rotation is there, P configuration will be given. Anti-clockwise rotation is there, N configuration is given. Here, whenever we are seeing this polynuclear compound, the ring which is inclined towards the VR is taken as a greater one, or it is of higher priority, so that in this direction we are moving, so which is regarded as an anti-clockwise rotation which is provided in this. So this is about the orientation, this is about the rotation of the plane polarized light, so that what happens from higher to lower priority, if we are moving, it is in anti-clockwise, it is regarded as M configuration. Whenever we observe the second compound where here cyclic ether system is there, so in contrast to CIP rules, what happens, rather than bromine, you have to assign the numbering for this heteroatom which is present in the cyclic system. So numbering will be started from oxygen rather than bromine. So 1, 2, 3, 4 arrangement will be there. This is of clockwise. This clockwise rotation is regarded as R configuration, right? So here starting M configuration, second compound will be R configuration, which is satisfied in the option number 1 only. So for question number 5, option number 1 is the right answer. Now let us move on to question number 6, where mass bar spectroscopy options are given. M by Z values are provided to us. Based on M by Z, we have to elucidate the structure of that unknown compound, whichever provided among all these 4, right? So M by Z values 121, 105, 77, 44, 4 different options are given. For all these 4 compounds, which compound is satisfying all 4 options? Let us predict that. For option number 2, all these 4 options are satisfying. Let us see how it is possible. When initial bombarding with electron, there is a possibility of radical cation. Radical cation is generated within the molecule. So that will be the molecular ion peak. M by Z will be 121. When we are bisecting the molecule in between amide linkage, so that here NH2 group will be discarded, M by Z of 16. And the remaining peak will be M by Z of 105 will be retained. And again cleaving the bond between carbonyl and benzene, so that we will get phenyl. Carbonyl of 25 M by Z will be discarded. Phenyl of 77 will be obtained. Now, in either possibility, if we are cleaving the bond between amide and phenyl linkage, this phenyl is of 77 will be obtained 1 piece. In either will be C double bond with NH2, that is amide linkage whose M by Z pertaining 44 is obtained. All these values are satisfied by the compound, this benzamide. This is the benzamide. So M by Z values are exactly suitable with this benzamide, hence option number right answer for this question. Now let us move on to next question. The major product formed in the following reaction. We are taking cyclohexene having C double bond with CH3 functional group at first position. Acetyl cyclohexene was taken. Now it is treated with tri-isopropylsilane in the presence of titanium tetrachloride compound. Whenever this is added, it is a kind of alkylation reaction. Here, this alkyl group, this olefinic double bond will be polarized in this manner. Here, carbocation will be generated. Being it is an electron rich in nature, it used to form a bond between carbon and carbon. So that here, this carbon involved in the bond formation here, and here is the linkage is possible, and a carbon positive charge will be generated here. Now, back polarization of this bond, and here the cyclization reaction is carried. There is a possibility of 4-membered ring within the molecule, and option number 2 is satisfying this statement. Let us move on to next question. Bicyclic system was taken where alpha beta unsaturated carbonyl functional group is there. It is treated with H2O to NaOH, being it is the epoxidizing agent. Epoxide is generated at this center. Option number A is the epoxide formation. In all 4 options, epoxides will be formed. But only the constraint is, it's the stereochemistry. So in 2 options, stereochemistry is given, inclination away from the VR. In 2 options, inclination towards the VR will be given. But in accordance with the steric strain minimization, what happens here, this group is towards us. That's why obviously epoxide will be generated away from the VR. Backside epoxide is preferable for this one. So that option number 1 or 2 may be correct for this. And subsequent treating with hydrazine. When hydrazine was treated, what happens here? Double bond hydrazone will be generated, and further subsequent ring opening, there is a formation of carbon-carbon double. Option number 2 is satisfying this statement. For this question, option number 2 is the right answer. Now let us see what is the suitable mechanism for this reaction. Whenever this hydrogen peroxide is treated with olefinic double bond, what happens? This olefinic double bond is added with this one from the back end, and subsequent epoxidation is possible. And treating with hydrazine in the presence of acetic acid, what happens here? We will get carbon-nitrogen double bond, which is known as hydrazone. This hydrazone further involved in ring opening type of reaction, and double bond is generated, and subsequent hydrolysis, this hydrogen derivative will be eliminated and hydrogen retained by this ring structure, so that we will get this OH group containing double bonded compound that is only satisfied by option number 2. Option number 2 is the right answer for this question. Now let us move on to next question. Match the following. Here 4 different hydride compounds are given: sodium hydride, beryllium hydride, hafnium hydride, technetium hydride compounds are given. We have to match with either the structure or properties of these compounds, right? Sodium hydride, being it is the first group element, always first group elements are saline in nature, salt in nature will be there. It is a part of saline hydride. Beryllium hydride, central beryllium is in electron deficient nature. That's the reason why its electron octet will be satisfied by polymeric chain formation. So polymeric chain is the right answer for this. Second B, right? Hafnium hydride, here you can observe hafnium hydride hydrogen is in 2.10. That means it is the non-stoichiometric ratio. It able to form interstitial hydride. Hafnium hydride is the interstitial hydride, where interstitial hydride stands for it is highly stable if there is no exact ratio is present in between metal and hydrogen. Extremely high elevated temperature and pressure conditions when applied, such a kind of interstitial hydride formation is possible. Technetium hydride is obviously taken as a tricapped trigonal prismatic compound. Let us see all these. Sodium hydride, when ionized, there is a formation of Na plus and H minus is possible. So it is regarded as a saline hydride compound. When beryllium hydride was taken, it is always in dimerized and subsequently polymerized structure will be there. Hydrogens behaving like a bridgehead hydrogens, and it exists in polymeric structure in this manner. So that's the reason why beryllium hydride is a polymeric chain, right? Now let us see technetium hydride. Technetium hydride is existing in tri-capped trigonal prismatic structure. It is the exact representation of tri-capped trigonal prismatic structure which is given for this technetium hydride. And one more is hafnium hydride. It is known as interstitial hydride because non-stoichiometric ratio is present in between. And this is of a stable kind of metal transition metal hydride it is. And exact fixed ratio of hydrogen and metal was not taken. And these are formed at elevated temperature. All these options, sodium hydride, saline hydride, option number A with 4 are given in 3 options. Beryllium polymeric, 1 is the right answer. Hafnium interstitial, 2, and technetium tricapped, 3. Option number 3 is the exact answer for this question. Match the following. Now, let us move on to next question, last question of this session, question number 10, where solid state chemistry was taken here. The degeneracy of the state having energy 27 h square by 8 ml square for the particle 3-dimensional cubic box of length L is given like this. Okay, so we have to find out degeneracy. So in order to find the degeneracy, we have to take this energy term 27 h square by 8 ml square. So here 3 coordinates nx square, ny square, and z square. Some of these values are given as 27, right? So in order to get 27, the 2 probabilities are 1 square plus 2 square plus 5, 1 square plus 1 square plus 5 square is equal to 27. This is one of the option. Otherwise, 3 square plus 3 square plus 3 square, this is also another option. So by using these 2, it is possible to obtain 27, where squares are given. So if we are taking nx, ny, and nz, these squares also removed. Now let us see what are the probabilities. Nx, ny, nz were taken. So nx1, ny1, nz was taken as 5. Whereas we change the position of these groups. 1, 5, 1. In this case also 27 will be obtained. And 5, 1, 1. This is another kind of probable orientation, right? So, and these three are possible with the first term. And second term is given as 3 plus 3 plus 3, 27, where it is not possible to replace because all three are identical in nature. The probable orientations are 1, 2, 3, and 4. So 4 degenerated states are available. Hence, for this question number 10, option number 1 is the right answer. So by this, we completed today's 10 question session. Hope it will be helpful for your preparation. Thank you. Thank you for your patient listening. Thanks a lot.